Hey everybody, this is Joe Price. So in this video, I'll be showcasing my latest Hoiktronics build. It's something that I've been working on for quite a while, since the 1.3 release, and it consists of a number of components that had to be independently created, independently designed. And I also had to come up with a way of simulating logic gates. And I found a really effective way of creating giant logic gates. So I'm going to break this up into two parts. In this video, I'll just be showcasing my latest build, and I'm also going to be showcasing improvements to my previous builds. And in the follow-up video, I'll make it into a tutorial video. I'll explain what giant logic gates are all about and how they have been used to create this latest build. So this build is actually on a different world, so let's head over there now. And let's check it out. Alright, so here we are. So this is just a freshly created world, and it just has this one Hoiktronics build. And here we are. Let's just get rid of that little mini-map. So this is an adder. It is capable of adding two numbers and generating an output. So that part is not really the exciting part. The exciting part is that this particular adder features decimal inputs and generates a decimal output. The previous calculators that I've showcased, the inputs had to be in binary. So this is quite a step up, quite an improvement over what I generated before. Well, let's not delay. Let's demonstrate how this adder works. Okay, so we'll just use this keypad to input the first number. Let's input 453. Now, notice what's happening here. When I pulled the 4 lever, the number 4 appeared in the 1's position. But when I pulled a 5, the 4 jumped from the 1's position to the 10's position, and in its place, the 5 was input. Then when I pulled the 3 lever, the 4 and the 5 shifted over by 1 position, and then the 3 got put in its place. This is a unique mechanism that I designed recently, and it was for the purpose of making this more calculator style. Alright, so we've input the first number, then we'll click on add, and the moment I do that, as I'm going to continue pulling these levers, the next number is actually going to be input in the top right corner instead. Alright, so let's input 254. There we go. And once I've input both of these numbers, I'll pull E for enter, and it'll take about 12 seconds to do all the conversions and do the actual addition. So there's a progress bar just at the very bottom here, and the number is about to come up shortly. There we go, 707, exactly the sum of these two numbers. Alright, so the C lever is just a clear lever. We'll clear all the inputs, and let's try this again. Now, these numbers that we're going to be adding, they don't have to be 3 digits. They could be 1 or 2 digits as well. For instance, let's try the addition of 23, and let's try another 2-digit number, let's say 78. Enter, progress bar shows up again, and we're about to get the output. There we go, 101, and yeah, that's exactly the answer when you add 23 to 78. Okay, let's demonstrate one more time. Let's say we input 234, and we'll add to that 98. Hit enter. We can input numbers from 0 to 99. There we go, 332, and again, exactly the correct answer. Alright, it's clear. And let's actually bring up the mini-map, just to show this whole build. As you can see, it's pretty big. So just to quickly describe the components of this decimal input adder. So the display is right here. And directly above is the sequential decimal input machine. There's actually two of them, one for each number that is to be input. So then in the follow-up video, I'll be just briefly explaining how this mechanism works exactly. Now, sitting right on top of this decimal input machine is a storage mechanism that stores the numbers initially in BCD format, so that's binary converted decimal format. And the purpose behind storing it in BCD is to then convert that BCD stored number into binary. So there's a shifter here, and there's this -3 function as well. It's all part of the algorithm to convert BCD to binary. And the two BCD numbers that are stored here, or the numbers that are stored in BCD, they'll be shifted over here. So up top will be the first number input stored in binary, and directly below is the second number that's stored in binary. So right below that is the ripple carry adder, which is designed to add those two numbers together, and it's binary addition that's being performed here. And the answer, the output, is in binary as well, and it's stored right at the very bottom. Now, as soon as the addition is finished, a converter kicks it to gear, converting that binary stored number into BCD, so it's stored in BCD down here. And right after that conversion, there's a follow-up conversion to convert it from BCD to decimal. So right up top are the actual converters. Now, most of these mechanisms, they rely on these giant logic gates that I've created recently. And these giant logic gates, how they're actually built, the logic behind them, I'll be explaining in a subsequent video. Now, there's one other thing that I just wanted to bring up here. If I just have a look around, as you can see, I'm using a lot of dummies. Now, Hoiktronics does require some sort of signaling agent, and previously we've used skeletons, and we've used town NPCs. More rarely, other types of mobs have been used. But we've recently discovered that we can actually use dummy ghosts. They're capable of actually traveling along Hoik paths. When you place a dummy down, it actually consists of two components. So one is the actual dummy you place, and there's also a so-called dummy ghost that actually ends up spawning at the same position that you place the dummy, so long as the player is within 100 tiles vertically and horizontally from that dummy. This is something that was discovered by Thiner on the official forums, the Terraria.org forums, and another member by the name of Z26 discovered that it's possible to actually hoik these dummy ghosts. So I've converted almost all of my mechanisms to use dummy ghosts. Yeah, so like I said, in a follow-up video, I'll be explaining exactly what's going on in some of these mechanisms, and I'll be particularly focusing on the logic gates here. So let's take a look at some other mechanisms that I've updated to use dummy ghosts. So I'll just return to my main world. I want to revisit a couple of builds here. So the first one is the slot machine, which now works a lot better, a lot faster with dummies in place. So the slot machine, we'll just pull the lever here. We have a $21 currently in our bank. It's always 21 when we enter. And as soon as I pull the lever, it'll randomize these three symbols, and it costs $1 to play. So every time I pull the lever, $1 is going to be deducted from the total. However, if three of the symbols match, then there's going to be a payout, either $10 if I get 3 sevens, or $20 if I get 3 diamonds or 3 spades. So let's take a look. Notice my bank total keeps going down with every pull. I notice that the randomization is a lot faster. If you've watched my previous video on the slot machine, you would note that in my previous version that used skeletons is a lot slower. With the dummies, it's much, much faster. Let's see if I can get at least 3 matching symbols here. There we go. So yeah, payoff was 10 bucks. So I'm back up to 15. Yeah, the objective here of slots is to break the bank, meaning we want to try to exceed $100. The moment that we exceed $100, here we win again. $10 got added. At the moment that we exceed $100, two things would happen. Number one is this vault door opens and we get access to the treasure chest inside, so that's one of our rewards. And the other reward is there's a number that's going to be revealed on screen. It's hidden from view right now. But yeah, once it is exposed, once we break the bank, well, that number can be used elsewhere in this map. Oh, look at that. Got 3 spades, $20 got added, we're up to 36. Yeah, so this is basically the updated slot machine. Works very, very nicely. So let's exit. And let's revisit another updated build, which is Blackjack. Yeah, so here we go. So right at the very bottom, we see a couple of dummies have been placed down there. And these have replaced the town NPCs that I used previously, and things work much, much better with the dummies. One of the reasons they work better is because the dummy ghosts do not move, whereas the town NPCs, well, during the daytime, they move around a little bit. Sometimes that might cause issues, misalignment issues when it comes to hoiks. Alright, so let's play a few hands. We'll need to bet first. We start off with 50 bucks in the bank, and the bottom left lever here allows us to input a bet. We can input anywhere between $10 to $40. So we'll start off with 20 bucks, and then let's hit deal. And some cards are going to be selected randomly. So the player gets the ace. Now in this particular design, the ace is locked at 11 points. Alright, so we get 11. And now a card is randomly drawn for the house, and the house gets a jack. Alright, so let's hit. See what happens. Oh, got a blackjack there. Alright, so we'll hit hold, and let's see if the dealer, or yeah, if the house can draw an ace. Oh, look at that. Unbelievable. What are the chances? 2 blackjacks. This version of blackjack doesn't actually distinguish between blackjack, so getting 21 on 2 cards, versus getting 21 on more than 2 cards. But yeah, I mean, the chances of having 2 21s are so slim anyways. Yeah, so that kind of defied the odds. Very weird. So in any case, the bank did not get adjusted. In the case of a draw, nothing happens here to bank total. Alright, so let's pull the new lever to play again, and it'll clear everything. Alright, so this time around, let's bet 30 bucks. Alright, let's hit deal. Player gets a 3, and the house gets a jack. Not a good situation for the player, but let's see what happens. Alright, so let's hit. That was pretty good. Get a 7. Alright, so we're up to 10. Let's hit again. Oh, that's pretty good. Gonna hold on 20. Let's see what the house draws. Oh, look at that. Oh, it's a tie again. Alright, let's clear. Let's try another hand. Alright, let's bet $10 this time. And let's deal. Good start for the player. And house gets a 5. So far, so good. Alright, hit me. Look at that. Another blackjack. Unbelievable. What are the odds? Alright, well, obviously hold. Alright. So at this point, in a real casino game, the house would lose. But like I said, in this particular version, it keeps going. And look at that. House gets a 21 as well. Unbelievable. Should go play the lottery. Alright. Let's hit you. One more hand. See if you can get anything but a draw. Alright, so this time around, let's bet 40 bucks. And let's deal. Yeah, so that was 3 aces, I believe, drawn from the deck already. Alright, so this time we're not in a good position, but let's see what happens. Let's hit. Huh, get a 6. That's nice. Alright, hit again. Gotta hit again. Alright, that's pretty good. We'll hold on 19. Yeah, a lot of cards have been removed from the deck, so it now it's taking a longer time to find cards. Alright, so 13. And the house bust. Finally we win. So our bank total is going to go up to 90. Nice. Alright, so let's try one more hand. Give the house one last chance to win. And we'll bet 10 bucks here. Alright, so let's deal. Yeah, the reason it's taking longer now to find the cards is because this randomizer, the way that it works is as soon as a card is drawn, it's removed from the pool. So the next time that same card is to be selected, it's not actually selected. The dummy ghost ends up cycling instead back to the start of the randomizer. So it might have to go through the randomizer a number of times if it keeps trying to select cards that were selected before. Alright, so let's hit. See what happens. Of course, I can reshuffle the deck at any time to make all 52 cards available again. Alright, let's hit again. $16, Alright, we'll hold on 16 and see what happens. House is up to 14. House will have to keep drawing. And the house busts. Alright, we've reached the 100 bucks. The objective of this particular game is to try to break 200. Once we break 200, another number will light up on screen here, and that number is to be used elsewhere in this map. Alright, let's clear and get out of here. Alright, so I hope you all enjoyed this latest showcase, and in my next video, like I said, I'll be explaining how giant logic gates work exactly, and I'll be going into a little bit more detail about the build that I just presented. Alright guys, so I'll make available both of the tutorial maps in the description box. I'll provide a link as well to a written guide to the giant logic gates and to this decimal input and output adder. I've published these guides before already on the official forums, so I'll provide the links. Alright guys, so we'll see you in the next video. Thanks for watching.